Okay, so a couple of weeks have passed since I worked on this amplifier, this Peavey amp, and during that time I had ordered a bunch of parts for it, and they've now come in, and I'm going to be putting them in and then do some testing, some cautious testing to try and be sure that we don't just blow things up again, because sometimes with these kind of amplifiers, if you haven't found the source of the problem, you can actually put new parts in and blow them up again. There's also the chance that there are other parts in the front end of this amp that could be bad, and we had no way of really testing that before, so we'll have to try and bring the power up slowly, check the current to make sure that it doesn't start to get away from us, and if we're able to bring that power up to full voltage, then we'll do some testing to see if the signal paths are actually working properly. So I'm going to pull this apart again, get in there, replace the resistors, replace the transistors, and replace that triac that was bad. Now, here's the board again. You can see in here the missing NPN transistor, so I'm going to put one in there first. So I have to solder these transistors in, as well as the other transistors that I had out before, because I haven't soldered them back in yet. These are the two I just installed. I'll solder those first. Now we will put in the resistors. I installed these 3.33 ohm power resistors, this 0.681 one, and these 3.33 ohms, and this 0.68, and I put in this triac here and soldered them in. So I've got all the parts basically in there now. All I have to do is trim off the leads of these components, and then we can probably do some testing. The big challenge here is to test this in a way that we don't cause it to blow up again. So always a good idea to be careful when you're trimming off these leads that one of them doesn't get away from you and end up somewhere down inside where it's likely to short something out. That would be embarrassing, to say the least. Okay, so I have put things back together, reconnected the cables and wires to the various parts of the circuit in here. Again, it was very handy to have taken some photographs before I started everything, because it's very easy to forget which colored wire goes to which terminal and so on. So I think I've got it back together. So the next step here is to bring up the power on this very carefully and make sure that there's not another short or fault in there somewhere that's going to cause sort of a cascading effect. And one way to do that, just to avoid potential problems is to use a variac. So this is a variac. And it's basically a variable auto transformer that allows you to adjust the AC line voltage from 0% to 100%. And actually that's not even quite accurate. With this variac, when you start with the control down at 0, it'll be 0 volts AC, but you'll get about 115 volts nominal line voltage when it's at the 85% mark, and when you go beyond that you can actually get somewhere close to 135 volts out of this. Of course, we don't want to do that in this case. What we want to do is we want to bring the voltage up very slowly, and the output is, and at this AC outlet here, there's a 12 amp fuse in here, and then what we'll do is we'll use a special cable that I made, nothing too fancy, but this is a cable I put together quite a few years ago for testing amplifiers. Basically what it is a two-prong AC plug. It's got an inline 15 amp fuse in this is an old format fuse, and also has a switch on it. And then what we've got is an outlet. Here. And then in series with this power line we've got banana plugs. And if you want to bypass it, I have a little bypass plug here. But in order to test this, what we'll do is we'll plug this into my my trusty old Fluke meter, my Fluke 77. I'm going to go through the 10 amp current range so that we can actually monitor the current, the AC current, as we bring up the variac. So I'm going to put that there. I'm going to plug into the variac. I'm going to make sure it's turned all the way down. Then I'm going to plug the amp in to the variac. And my other meter I'll just have here just in case I need to make some other measurements as we go. I'm plug the variac into the wall outlet. 0 volts coming in. I'm going to be watching this current meter. I'm going to turn on the power here to start with and see what happens. Okay, we've got 0 volts AC going in. Okay, there's power to the variac. Okay, we'll bring up the voltage. We're seeing a little bit of AC current, 100 milliamps maybe. Now, I don't know what current we should be looking for exactly, but if it all of a sudden starts to ramp up very quickly, we'll shut it back down. We're actually up to about 30, maybe 30 volts in, and we're at about 1/4 of an amp. It's got to be drawing some current when it's just sitting idling. We're up to 1/2 an amp. The fan is running. I don't see anything happening that looks scary. Okay, I think we're pretty close to line voltage at this point, and we're drawing about an amp. So now I'm going to test my DC power supply voltages. So there's -74 volts, and there's positive 74 volts. That's a little lower than what I would have expected. Let's try this other one here. Again, 73 volts on the other side. These are different power supplies for the different channels. Well, those DC voltages seem a little low, but it looks like we don't have a catastrophic situation happening here, at least. So I guess the next step would be to connect up a speaker, or some kind of a load at least. I've got a dummy load I could use, and a signal. See if we get anything through this thing. Alright, so this is a dummy load that I made probably 35 years ago, 40 years ago maybe. It's basically just two 10 ohm 225 watt resistors, and these ones have a tap, so you can run this tap anywhere off there. So I've set this to about 8 ohms, so when I connect that up to the output of an amplifier, it's presenting a resistive 8 ohms to that amplifier, and the two resistors are so that I can test in stereo. So I'm just going to hook this up to the output, and then I'll put my oscilloscope on it so that we can see the signal output and make sure that it'll operate into a load. Okay, so I've got that hooked up now, and I'm going to start by connecting my scope across the A channel. I've connected my signal generator into channel A, and this has got a level control on it. It's set to about 50%. So I'll turn on my signal generator, keep the signal level down to start with. It's running at about 1 kilohertz. I'll bring up my signal a little bit. I'll hit auto setup again so it'll reset its parameters. So I do have some sort of a signal there. If I bring up my level on the amp itself, signal is coming up. And that's measuring the voltage across the power resistor. At this point I have no idea whether that's a appropriate level. I know my signal's fairly low that I'm sending in there. Current is still down around 1 amp. I'm going to switch over to the other resistor and switch my signal. Bring my signal level up. It's odd I don't have anything there that I can see, which makes me suspect that there still could be a problem with that channel. So the testing that I've done so far has basically shown that one channel seems to have some signal through it, the other one does not. Now, it's hard to tell with that particular test whether or not the signal that's coming through the one channel is actually enough. It was looking pretty noisy, and I didn't know how much gain I should be seeing at that point. So I decided that I need to take a step back and look in the front end of this amp for the power supplies there. It's always a good place to start testing to make sure you have your power supplies. And what I found was that the plus minus 15 volt power supply that supplies the transistors and op amps in the front end was not there. I'll just show you on the schematics, not the best schematic, but so AC is coming in through these fuses, and then it's going to this bridge rectifier here. It's actually a bridge made out of discrete rectifier diodes. There's two capacitors, filter capacitors here and here, and the common is in the middle, and then from there we go out through some power resistors to some Zener diodes. So these are 15 volt Zener diodes, and what I found when I did some measuring was that I was getting about 40 volts out of the bridge all the way across, or 20 volts each side. So I was getting voltage on this side of these power resistors and down there, but I wasn't getting anything on the other side out of the Zener diode. So I'm suspecting either the Zener diodes are both damaged, or else it's shorted out further on and pulling those voltages down. The voltages on the outputs of those Zeners were somewhere in the neighborhood of like 1 or 2 volts. So I'm suspecting that these 15 volt Zener diodes may both be bad. Now I did a ohmmeter check on them and they look good, so I might be wrong about that. Here's a view of the power supply and front end board. This is the connector where the AC power comes in. Here's the individual rectifiers that rectify that, the filter capacitors associated with it. And so across those filter caps we do actually have 20 volts DC. Down here we have one of those Zeners, there's the other Zener, and then there's some capacitors on the output side of the Zeners. I'm going to proceed with changing out those Zener diodes. Okay, so I brought up the power supply. On the plus side I've got 2 volts, and on the minus side I got -1 volt. So that would indicate that the problem was not those Zeners. So I've got to come up with some sort of a strategy to figure out what further down in the circuit is loading down that 15 volts power supply. So I apologize for the fact that I didn't get a lot of the rest of this fix on video. At some point in some of these repairs, you get so far into the techie side of it and the analysis side of it that it's very difficult to remember to get all of the video side of it together. So the rest of this video is going to be a little bit of a hand waving exercise, as I would call it, to describe what I did and show you on the schematic where these various components fit into the circuit. For those of you who like to kind of geek out on the technical side and the schematic side of things, this might be helpful to you. So here's the schematic diagram of the front end of that circuit. It also shows the power supplies. And the power supplies for the power amp section are shown on this part. Here's one power supply, shows the AC coming in here. You've got a bridge rectifier and you've got a filter. And these are the power supplies that are supposed to be 82 volts for the A side and the B side of the power amp. So we dealt with that before, and we were getting around 72 volts. So it was a little low, but probably not a problem. The power supply for the front end is here, as I mentioned before. So this is the A section of the front end, and this is the B section of the front end. There are several op amps in here. They're 4558s, and there are some discrete transistors in the output here that goes to drive the power amp section. And in the end, what I found was that there was an op amp here that was faulty, a 4558, and I didn't have a 4558 at that point in time, but I did have a 5532, which is a newer lower noise op amp with the same pinout, and so I put that in there and tried it, and it actually did help the situation. Replacing that got me back my 16, but I still didn't have my 15 volts, and so I had to look further. And what I found in the end was that one of these transistors, when I looked closely at it, was actually physically damaged. And I believe that that was the snap that I heard when I first powered this thing up, and it actually blew the top off that transistor. And it was down in the circuit board so far that it wasn't easy to see. So I replaced that. That was the NPN complement to that, so I replaced that as well. At that point, I still didn't have my plus minus 15 volts in this section. I went looking further, and I found a bad Zener here, and I tried replacing these ones. I don't think they needed to be replaced, but I did anyway. Once I replaced this Zener diode right here, my 16 volt and 15 volt plus and minus supplies came back, and I was able to put a signal into the amplifier and get a good signal out on my dummy load. So here's the amp, fully functional. I'm just going to turn it on and show you the signal in and out. And I'm going to bring up the input signal on channel A. And there on the scope you can see the output. Now I'll switch over to channel B. And this is the one that was faulty. Bring that one up. Same thing. So that's looking like everything is working correctly. In the end, I replaced 2 power transistors, 8 power resistors, a triac, 2 small signal transistors, and about 4 or 5 Zener diodes, as well as a 4558 op amp. So that's quite a few parts. Anyways, I hope you enjoyed this fix. It certainly was a challenge for me, and took me quite a while to get through all the steps of it, and I still have to put some of the screws back in, put the boards back together, and do a final test once the cover is on. But I believe this one is complete. Hope you enjoyed it. Hope you've got something useful from it. If you did, I'd appreciate if you'd leave me a comment. If you have any questions, that would be great. Feel free to give it a like. So we'll see you on the next one.